This is Shirisha. In this project, I extended the previous skipgram or CBOW to vector implementation by replacing the standard output layer with hierarchical softmax. The main objective was to understand how a Huffman tree can be used to efficiently compute word probabilities without evaluating a full vocabulary size softmax for every training example. This project covers building a Huffman tree from vocabulary word frequencies, assigning every word the binary path phi w, a list of internal nodes along that path, implementing hierarchical softmax as the output layer, deriving and coding gradients manually for internal node vectors UI, context or word vector VC, verifying the probability distribution numerically, comparing three different output layers, full softmax, negative sampling, hierarchical softmax, comparing training time, memory usage, final loss, and nearest neighbor quality. Comparing a Huffman binary tree with a random binary tree, measuring average path length and training time. Huffman tree. The Huffman tree is constructed using the frequency of words in the vocabulary. Frequency words receive shorter paths, while rare words receive longer paths. For every word, the implementation stores pi w is equals to binary path and nodes is equals to internal nodes along the path. This allows the probability of a word to be computed by following its path from the root of the tree. Hierarchical softmax. Instead of calculating probabilities for every word in the vocabulary, hierarchical softmax calculates the probability by multiplying the binary decisions along the word's tree path. This changes the computational complexity from approximately big of V for full softmax to approximately big of log V for a balanced or Huffman style tree. Gradient implementation. The gradients are derived and implemented manually. For each internal node on the target word path, the model updates the internal node vector UI, the input or context vector VC. The implementation does not rely on automatic differentiation. Probability validity check. For a randomly selected context vector, the probabilities of all vocabulary words are calculated through the Huffman tree. The following condition is verified. Sigma PW, P of W by VC is equals to 1. The difference from 1 is reported using a numerical tolerance. This confirms that hierarchical softmax represents a valid probability distribution over the vocabulary. The output layer comparison is the same corpus and the number of training epochs are used to compare. In full softmax computes probabilities for the entire vocabulary. Negative sampling. In negative sampling, updates the positive target and a selected number of negative samples. Hierarchical softmax uses the Huffman tree and only updates the internal nodes along the target words path. Thank you.